moving coil galvanometer is a device which is used to detect the flow of current in an electric circuit. When a current carrying loop is placed in a uniform magnetic field, it experiences a torque. Construction. A moving coil galvanometer consists of a rectangular coil. The coil has large number of insulated thin copper wire. The coil has a large number of turns of wire wound over a light metallic frame. A cylindrical soft iron core is placed symmetrically inside the coil. The rectangular coil is suspended freely between two pole pieces of a horseshoe magnet. The upper end of the rectangular coil is attached to one end of fine strip of phosphor bronze, and the lower end of the coil is connected to a hairspring which is also made up of phosphor bronze. In a fine suspension strip, a small plane mirror is attached in order to measure the deflection of the coil with the help of lamp and scale measurement arrangement. The other end of the mirror is connected to a torsion head. In order to pass electric current through the galvanometer, the suspension strip and the spring are connected to terminals. Consider a single turn of the coil whose length is L. The electric current flowing through the rectangular coil PQRS. The horseshoe magnet has hemispherical magnetic poles which produces a radial magnetic field. Due to this radial magnetic field, the sides QR and SP are always parallel to the magnetic field B and experience no force. The sides PQ and RS are always perpendicular to the magnetic field and experiences forces in opposite directions. Due to this, torque is produced. It's for single turn, the deflecting torque is equal to BF is equal to F is force is equal to for BIL, then LB into BI is equal to LB is area for the coil is LB, and so ABI. Torque is equal to N of NABI. Due to this deflecting torque, the coil gets twisted, and restoring torque, also known as restoring torque, is restoring couple is developed, and hence the moment of restoring the torque is proportional to the amount of twist theta. Thus, torque is equal to K theta. K is the restoring couple per unit twist. At equilibrium, the reflecting couple must be equal to the restoring couple. NABI is equal to K theta, I is equal to K theta by NAB, I is equal to G theta, where G is equal to K by NAB is called galvanometer constant or current reflection factor of the galvanometer. Since the suspended moving coil galvanometer is very sensitive, we have to handle with high care while doing experiments. Most of the galvanometer we are using are pointed type moving coil galvanometer. Figure of merit of a galvanometer. It is defined as the current required to produce a deflection of one scale division in the galvanometer. The galvanometer is said to be sensitive if it shows large scale deflection even for a small current pass through it. Current sensitivity is the deflection produced per unit current flowing through galvanometer. IS is equal to theta by I. Theta is NAB by K. IS is equal to 1 by G. The current sensitivity of a galvanometer can be increased by increasing the number of turns of the coil, increasing the magnetic induction B, increasing the area of the coil A, decreasing the couple per unit twist of the suspension wire K. So NAB by K. And phosphor bronze wire is used as the suspension wire because the couple per unit twist is very small. Voltage sensitivity is defined as the deflection produced per unit voltage applied across the galvanometer. Vs is equal to theta by V. Vs is equal to theta by IR. Theta is NAB by K and NAB by K into RG. Theta by I is NAB by K into RG. Vs is equal to 1 by GRG is equal to IS by RG. RG is the resistance of the galvanometer. The conversion of galvanometer to ammeter and voltmeter. Galvanometer is very sensitive instrument to detect the current. Galvanometer ammeter is an instrument used to measure the current flowing in the electrical circuit. The ammeter must offer low resistance so such that it will not change the current passing through it. So ammeter is connected in series to measure the circuit current. Galvanometer is converted to an ammeter by connecting a low resistance in parallel with the galvanometer. This low resistance is called shunt resistance. The scale is now calibrated in ampere and the range of ammeter depends on the values of the shunt resistance. An ammeter is a low resistance instrument and it is always connected in series to the circuit. An ideal ammeter has zero resistance. In order to increase the range of an ammeter n times, the value of shunt resistance to be connected in parallel is S is equal to Rg by n minus 1. Galvanometer to Voltmeter is an instrument used to measure potential difference across any two points in electrical circuits. It should not draw any current from the circuit, otherwise the value of potential difference to be measured will change. Voltmeter must have a high resistance and when it is connected in parallel it will not draw appreciable current so that it will indicate the true potential difference. A galvanometer is converted into a voltmeter by connecting high resistance in series with the galvanometer. A galvanometer is connected into a voltmeter connecting high resistance in series with the galvanometer. The value of resistance is so adjusted so that current Ig produces full-scale deflection in the galvanometer. Let Rg be the resistance of galvanometer and Ig be the current with which the galvanometer produces full-scale deflection. The deflection in the galvanometer is proportional to current Ig, but current Ig is proportional to the potential difference. Hence, the deflection in the galvanometer is measure of potential difference. Since the resistance of voltmeter is very large, a voltmeter is connected in parallel in an electrical circuit will draw least current in the circuit.